Today we're going to look at how to determine a quadratic rule. Now the coordinates of up to 3 points are needed to find a quadratic rule, and in general we'll find the rule by substituting points that are given or that we can work out for ourselves from the information. Now the form of the equation may be stated, otherwise we can choose whichever is most convenient. The three basic forms are expanded form, y equals ax squared plus bx plus c, factor form, y equals a bracket x minus a bracket x minus b, and turning point form, where we use the letters a, h and k. Just take note that for forms 2 and 3, factor form and turning point form, the value of a is the same. Now let's look at some examples. So let's say we have a parabola that has x-intercepts at 2 and at -4 and passes through the point 1, -15. In this case, it would be a good idea to use factor form because we know the x-intercepts. So we write y equals a, x minus b, x minus c. And of course in factor form, this tells us that the x-coordinates of the x-intercepts are at b and c. So ours are at 2 and -4, so our brackets will contain x minus 2 and x plus 4. The thing is, we don't know the value of a. It may be 1, but it might be something else. So what we'll do is substitute in the other point, remembering that x is 1 and y is -15. And so we have -15 equals a 1 minus 2 in brackets, 1 plus 4 in brackets. We've just replaced x with 1. We work those brackets out first before multiplying, and so we end up with -15 equals -5 times a, and by dividing both sides by -5, we quickly come up with a equals 3. So now we know the value of a, we can write the equation fully as y equals 3 bracket x minus 2 bracket x plus 4. Notice that the x-intercepts alone were insufficient because there exists a whole family of parabolas that have the x-intercepts of -4 and +2. So the value of a, in this case 3, acts as a dilation factor and stretches the parabola when a is greater than 1 and dilates it to make it wider when it's less than 1. So each member of the family has a specific value of a, the dilation factor. In this next example, we're going to find the equation of a parabola with a turning point at 2, 6, and which has a y-intercept of -6. Now, we read that as 0, -6, because those coordinates are going to be substituted later. Now, the fact that we know the turning point is very handy because that means we'll use the turning point form, which is a x minus h squared plus k. And as you can see there, if I substitute in the values of the turning point, which are 2, 6, meaning we'll have x minus 2 squared plus 6. Really all we need to do is find the value of a, and we again do that by substituting a point that we know is on the parabola, 0, -6. So when y is -6 and we replace x with 0, because it is the y-intercept, we'll end up with -6 equals 4a plus 6, and ultimately come up with a equals -3. So that tells us that the parabola is going to be inverted, as we see over here. So the first thing to do is we draw our parabola with the turning point at 2, 6. We recognise that it's going to be inverted, and then we extend it to the y-intercept, or past the y-intercept here at 0, -6, if we were asked to draw it as well. In this case we were just asked to find the equation, but it's useful to do a sketch graph as well. In this third example, we're going to look at the case where we have a parabola passes through 3 points. So we're given the coordinates of those points, 1, 4, 0, 5, and the other one, -1, 10. Now because we don't know the turning point, we're not going to use turning point form. We don't know any x-intercepts, so we're not going to use the factor form. So if the form's not specified, then what we'll just use is the expanded form y equals ax squared plus bx plus c. Okay, so what we're going to do is obtain three equations and solve simultaneously. So first we'll substitute our point 1 and 4, and when we do that carefully we get an equation 4 equals a plus b plus c. We do the same with 0, 5, and we get the equation 5 equals c. We'll label that equation 2. And then we'll do a similar thing with the point negative 1, 10. So if, in effect, we get three equations, and we have three unknowns, so we should be able to solve those simultaneously. The fact that we know that c is 5 means we could substitute that directly into the first and third equations. And as you can see there, I'm going to obtain a plus b equals negative 1, and over here, which what I'll call equation 5, is a minus b equals 5. Now if you look at those two equations, we could add those together to eliminate the b, and that way we'll get 2a equals 4, and so we know that a is 2. And of course once we know a is 2, we could just go back to either of those equations and substitute it in. In this case I'm going to do it into equation 4, so 2 plus b is negative 1. I get b as minus 3, and so now I know the values of a, b and c. I can just write the rule down. 2x squared, y equals 2x squared minus 3x plus 5. And that's it.